Welcome to Web Handling. My name is Dave Roisum. In this second video on drives for lightweight or thin webs, we look at mechanical design strategies. Recall from our last video that tension changes going over every idler. We gave an example of a case where bearing drag caused a tension rise of 5 newtons and inertia was twice that big, even though inertia is in effect only during speed changes. Now we will work with the real world instead of made-up problems. What we need to do for good design depends greatly on the details of the application. Guessing is no substitute for numbers. We can measure bearing drag using a weighted strap, or, much better yet, the spin-down test that I gave in my Mechanics of Rollers book back in 1996 and was expanded on by Tim Walker a decade later. In fact, we have to measure drag because it cannot be calculated. Beware, drag can vary 2 to 1 on bearings right out of the box and as much as 10 to 1 after a time in service. Thus, we need to add a generous safety factor here. Then, we calculate the inertial tension upset knowing roller geometry and the acceleration rates of the machine. This is well documented in my roller book. Now, depending on which component is bigger or more serious, we get a different set of options. Of course, the size of the delta T is relative to the number of rollers you have, as well as the average tension and the tension quality you need. You might wish, for example, that the tension did not rise more than, say, 10% in any drive zone if the process is fussy. If bearing drag is larger, we will first reduce roller count. Then we will consider redesigning the bearings to go from grease to oil, from seals to shields to open bearings, and finally to increase the ABEC or quality class of the bearing. Of course, space-age bearings need decent maintenance, so all of this effort is not lost a few years later. If inertia is the larger, we must first reduce roller count. Then we will make sure all rollers are properly sized for deflection, such as Class B. We might be able to reduce wall thickness. We could even consider carbon fiber, even though there are cost and design and maintenance issues to consider with these high-tech rollers. As a last sanity check, we must make sure that the acceleration rate is no higher than might serve some useful purpose, such as maintaining productivity on machines that start and stop many times an hour. As we notice, reducing idler roller count is the very first step of a good web machine design practice. In fact, the maximum allowable number of idler rollers between any two drive points is a calculation. This procedure, with worked out examples, is given on pages 60 to 61 of my roller book. Of course, there are many other things to tend to when designing machines to run lightweight materials, as given in my 2003 article. For example, wrap angle must not be too much nor too little. Also, as we will outline in the next video, drives need to be designed and tuned with great skill. Thank you so very much for watching this module in my Plant Practical series. If you want to understand the foundation for these design recommendations, consider going to my Web 101 school. If you want to see the design calculations with worked out examples, consider my Mechanics of Rollers book.